Hey guys, thanks for joining again. Wanted to do this video on the topic of using expansion regions and show an example of what that may be useful for. This topic came up as I was working with someone on a project, and an expansion region looks something like this, where you have various ways to parse through data and then act on that either iteratively or in parallel. We found a neat use for this, and what I'd like to show is how you could actually add up various instances of things. So it may be the case that you have several instances of something. So in this case, I have a few instances of a block, and they have different slot values for the system values. So from one instance, the slot value for this is 10 and the other one is 20. And if you look in the containment tree, we have these two instances here. One of them is named system, the other one's named system1, and then you have system value being 10 for its slot value, and then another one that is 20. So we came around to the idea that we may want to sum those up and then do some other math with that after we've summed it up. So the question is, how do you instantiate multiple instances and then act on those? And one of the ways you can do that is by using an expansion region that essentially parses through that. But you have to first create a collection of those objects. To do that, what I did is actually create another block that has this system as a part property, and then notice it has the asterisk for its multiplicity, meaning there can be more than one system as a part of this sum of instance values block. What I did then is create an instance of this block after I already had two instances of this block. So for the system block, there's two instances. For this block, I created one instance. So I went to the sum of system values instance that I created. So we're talking about a lot of instances here now, but this is the specification for this block's instance. And if you go to the slots, what you can do is create new values, and notice it gives you the option to add them to the right. So when you do that, it'll actually create a collection of these instances, and then that specific instance will hold multiple instances of that system block. So then the question is, how do you actually act on those individually and then sum them up? So to do that, I created an activity diagram as the classifier behavior of this block. And then if you use the read self action, it'll read that instance. Of course, we have to run this from the instance at that point, but it'll read itself, and then it's going to read the structural feature, which is the part property, in this case called system. And if you're curious about how to get to these, if you go to your action drop-down menu and then go to any action, you have the read self action, and that simply reads all of the data, all the structural features of that block that is executing that activity. So in this case, it's that sum of instance values block. And then to get down to various part properties or value properties of that, you can then use the read structural features. The read self is this one here, and then read structural feature action is this. And you can read any type of a structural feature, that being value properties, constraint properties, part properties, reference properties, and ports. Those are those 5 different types of structural features, all of which you can read with that read structural feature action. And you simply drag that structural feature onto that, and then it'll narrow down what it's outputting to only things that are of that type. When you get to this expansion region, notice you have this expansion region option here. And then you can input into this as a pin. You also have the option to output something out of this. And notice it has these, what looks like 4 inputs, but that doesn't mean 4 of anything. That simply is the icon that expansion regions use as an input to denote that it can accept a collection of things. So that's what really that is intended to be. Once you're inside of that, I used a read structural feature to read the system value, because we're looking at the system and then its system value. And then it's going to iteratively look at those objects that are passed from that instance. So when we run a simulation of this, what you'll notice is it goes through those individually. So we had 10 there and then 20 there, and then it passed the entire array as an array. And then this has a multiplicity of an asterisk, meaning it can accept multiple inputs that would be called X. And then we simply sum them up using the built-in math language, and that's how you got your result there. Then of course that value could be then acted on in a parametric or taken into another expression somewhere else in this. But I thought that was an interesting use of expansion regions in use with the collection of objects that you could have as instances, and then how you could act on those together. Let me know what you guys think about this. I found it pretty interesting and useful to do. I'd like to hear what you guys have to say as well. Thanks a lot.